Good evening, everyone, and welcome to the WOHOP lecture co-hosted by the Department of Civil and Environmental Engineering and NUS cities. Just a housekeeping request, please ensure your devices are on silent mode or powered off. The WOHOP Distinguished Lecture is a distinguished lecture series made possible from the generous donation by the WOHOP Group, covering topics in different areas of civil and environmental engineering. The NUS Cities Lecture Series investigates policies, ideas, and projects developed by urban experts which aspire to create sustainable, resilient, and livable cities. Through the lecture series, we hope to create a platform for discussion, retrospection, and conversation to give momentum to the ongoing research and exploration regarding the issues concerning cities. I would now like to invite on stage the moderator for the evening, Prof. He Xiaokang. Prof. He is a Princeton-trained PhD hydrologist with experience in economics, machine learning, and environmental policy. His research interest focused on the fundamental understanding of how climate change, variability, and human interventions affect drought and flood risks across scales, and how to implement an integrative framework to reduce their societal impact. Please join me in welcoming him on stage.
Thanks, Sarjana. Good evening, everyone. Thanks for coming. My name is He Xiaokang. I'm an assistant professor in the Civil and Environmental Engineering department. So today I have the great pleasure to introduce the speaker of the event, Professor Michael Oppenheimer from Princeton University. So Professor Oppenheimer is Albert Milbank Professor of Geosciences and International Affairs at the Meadows Environmental Institute, as well as the director of Center for Policy Research on Energy and the Environment of the School of Public and International Affairs at Princeton University. Professor Oppenheimer is a global leading expert on sea level rise, coastal flooding, climate science, and coastal protection and adaptation. So his scholarly contributions are internationally recognized with many prestigious awards. Professor Oppenheimer is longtime participant in IPCC, the Intergovernmental Panel on Climate Change, that won the Nobel Peace Prize in 2007. He also served as an author during all 6 IPCC assessment cycles, including most recently as a coordinating lead author on IPCC's special report on oceans and psychosphere in a changing climate, published in 2019. And he is also a review editor on the most recent 6 assessment report. Professor Oppenheimer served previously as a member of several panels of National Academy of Sciences, as well as the National Academy's Board on Energy and Environmental Studies and the New York City panel on climate change. He's also a winner of the 2010 Haynes Award and a fellow of the American Association for the Advancement of Science. Professor Oppenheimer is the co-editor-in-chief of an interdisciplinary journal, Climatic Change. And most recently, in 2021, Reuters launched the hot list ranking of the global top climate scientists who has influenced the debate of climate change. And Professor Oppenheimer is listed as the pioneer. So I could probably go on for 20 minutes talking about Professor Oppenheimer's achievements, awards, and scientific influence, but I won't. So with that, please join me in welcoming Professor Oppenheimer to speak to us.
Thank you, Xiaokang, and thank you to everybody here, particularly to my hosts. I want to say that I've not only felt very welcome, but I've been surprised to learn, not really surprised because I came here expecting to learn quite a lot about how Singapore is dealing with the issues that I spend so much of my professional life dealing with, that is climate change and the threat of sea level rise. And I'm very pleased to learn that in some ways Singapore provides somewhat of an example and that the rest of the world could look to in being able to think ahead, which is something which probably is no surprise to you. Most governments have great deal of difficulty doing. And it is to Singapore's credit, and we'll see how it plays out, of course. We can come back in 50 years. I won't come back, but perhaps many of you will still be here and be able to look at how things, what the results are. And it's easier for Singapore, in a way, being basically one spot on a map, to be able to plan ahead, and particularly with the kind of very unified form of government you have. But no matter what, it's going to provide, I think, a learning example for a lot of other governments. I hope they pay attention to the way that you're going about it here. I want to say that in this talk, first of all, I hope you don't mind. I'm going to take my jacket off because despite all the air conditioning, it's a little warm up here. I'm going to assume that you have a basic knowledge of climate change. I'm not going to repeat the details on the fact that Earth is getting warmer. It's already actually almost 1.2 degrees Celsius warmer than in pre-industrial times. I'm not going to repeat the facts in any detail about how that's been attributed to the buildup of the greenhouse gases, carbon dioxide, methane, nitrous oxide, where the main sources are fossil fuel burning, deforestation, and a number of other sources that relate to human activity. And I'm not going to talk a lot about other impacts of climate change, except to say that the emphasis I'm going to have on extreme events and their importance really is true of not just climate change, not just sea level rise, but many of the other aspects of the problem. Now, I bet we're going to have a problem from the outset. Let's see if we can fix this problem, because otherwise we're not going to have a talk. No. This is one of the few talks I've ever had that has 2 introductory slides. Okay, so what's this talk about? Number one, this is going to focus on the hazard, the coastal hazard that results from sea level rise, and the possible policy responses, on the deficiencies of some of the policy responses at some places around the world, and what we can do about them. We're going to emphasize extreme events. The trend in sea level, just the gradual rise, is in itself important, of course, in taking away habitable land, but I'm going to focus on the extremes. What happens during a particularly high tide? What happens during an extreme storm? The kind of storms which you don't have. You're lucky you don't get them in Singapore, but tropical cyclones and the flooding that results. I'm going to talk about projections for how the frequency of these events is going to increase as the climate changes and as the Earth warms, as the sea level rises as a result. And I'll talk about some of what the specific causes of sea level rise are. And I'll talk about what is being done in various countries around the world. I'm going to put an unfortunately heavy emphasis on my own country, the United States, because that's where I'm most familiar, but I know what's going on in most other places along the coast, and talk about adaptive responses and the increasing in the dealing with the risk that we well know is coming, how that dealing with it has been rather limited in most places, and in fact has been limited to some thinking, a lot of talking, and not much actual implementation. And the question then becomes, why is it so difficult to deal with a problem that governments and many individuals know is headed our way and in fact has already begun? What is it that are the barriers to action? What is getting in the way? So the key question is here at the top. Are countries capable of doing the kind of long-term planning, the kind of visioning what the future will look like, whether the kind of societies that we have envisioned actually fit into the future when the coast becomes a more dangerous place, and what kind of world we should be building which will protect the coastal civilizations that are there now in an era, in fact, when migration towards the coast, while construction of infrastructure along the coast while the economic importance of the coastal zones has done nothing but basically increase around the world. So as I said, there's been a lot of talk, there's been some planning, but even in places where there's been a lot of planning, like the Netherlands, for instance, it hasn't been comprehensive. To my knowledge, and we have some Dutch experts in the audience, they've made very good plans and some implementation for protecting the coast, their coast, up to 2 meters sea level rise. But it could be we're going to actually get more than 2 meters. Is that correct? Yes. And they don't know exactly what to do. We can put them on the spot later. So and here's the most important point, that the changes are coming faster than our ability to actually make long-term plans. That if you were going to plan to defend the Netherlands to 2 meters, or my country to even 1 meter, you would have to start thinking, financing, making specific plans, and implementing that whole process, which can take 50 years. We have experience that says so. You'd have to start that now. And some countries are just not in a position, including my own, to start that now. So it's nice to see that Singapore has a little headway, but headway has a way of evaporating because the climate has a way of running faster than we expect. And to my mind, the key point is that these extreme events that I'm going to talk about are going to be coming with less and less space between them. They're going to be coming more and more frequently. And at some point, they come frequently enough so that there isn't sufficient time to recover between these events. And that's just talking about coastal extreme events from sea level rise. There are other extreme events that are going to be happening at the same time, generated by climate change, which are going to also require our attention, our planning, our finances, and we may not be in a position at many places around the world to actually deal with that combination of events. Many of the extreme events related to climate change are going to be becoming more and more frequent, so that space between damaging events is going to shrink. And if it really takes I come from a city with a big hurricane in 2012. It's 11 years ago, Hurricane Sandy. We are still doing repairs. The way I got to the airport to get on a plane from New York City, I had to go to Newark Airport, which is across the Hudson River. It took me 20 minutes longer to get there than it would have otherwise, because the main tunnel that goes to that area of New Jersey from New York was closed every evening now, and on the weekends longer, till 9 in the morning. And my plane was at 9, and I had to be through the tunnel and to the airport a couple of hours early. And why? Because they're still repairing the tunnel because of Hurricane Sandy. There's a railroad tunnel under the Hudson River that was damaged during Hurricane Sandy. They haven't repaired it yet because they have to get the money together to build another tunnel to replace the first tunnel while they shut down the original so they can repair it. Infrastructure does not get fixed overnight, and that's the main problem we're going to have. So, and by the way, while all that's going to happen, there's all kinds of random stuff that's going to happen in the world that's going to divert the attention of governments. Like, what do you see going on now? There's a major war going on in Europe. Did anybody plan for that? Was it expected? Has it messed up the energy system, the energy markets? Yes. You can't plan for that. So you have to expect chaotic things to happen, and protecting the coast is expensive. It can't, when something else comes in the way, it diverts resources. One of the bottom lines of my talk is we have to have a way in all countries that have a coastline to generate the resources on a continuous basis so the planning and implementation can proceed. Human beings are capable of doing that. We have done it for infrastructure in the past. It isn't clear that we have the understanding and the willpower to do it for coastal defense at this point. So what can be done? What can we expect? So first, let's talk about what the risk is. So this is just a schematic. I'm going to explain here why sea level is rising. there are four main sources, and really three. When you heat the atmosphere, you heat the ocean. When you heat the ocean, you cause it, like most fluids, to expand. And when it expands, that's effectively sea level rise. That's called steric. That's a steric problem. That is, it's called it's thermal expansion. But there's another steric element. The other steric element is that the salinity of the ocean causes expansion or contraction when it changes, and that's making a minor contribution to this term. So let's not worry about the salinity part too much. Let's just think of it as a heat-related problem. Secondly, mountain glaciers melt. If you warm ice, eventually, if you warm it enough, it's going to melt. Glaciers are retreating worldwide. Where does the water go? It goes in the ocean. It raises sea level. Thirdly, the huge ice sheets, there were two remaining large ice sheets in Antarctica and Greenland. They contain an equivalent of over I think it's 68 meters of sea level rise, a little less than that, let's say 65. 65 meters of sea level rise. Luckily, most of that is in central Antarctica, East Antarctica, and it's probably, now I'm saying probably because nothing in this problem is for sure, it's probably stable unless we let the Earth warm by double digits, 8 or say getting up to 10 degrees Celsius, and it would take thousands of years to run off into the ocean. That's not the part of the problem I'm worried about. I'm worried about what's happening mostly at the fringes of Antarctica, where you could get several meters of sea level rise relatively quickly, maybe 4 meters out of West Antarctica in the matter of a couple of hundred years. Do the calculation yourself. That's a very fast rate of sea level rise compared to what we're used to. And Greenland, the Greenland ice sheet might melt totally away, but it will probably take a couple of thousand years. That 7 meters is a lot, but spread over several thousand years, it's not quite the threat that Antarctica is. The difficulty is we don't know how to model Antarctica very well. We cannot make a sound prediction of what the ice is going to do beyond about 30 years from now. I feel confident in the projections we have for 30 years from now from Antarctica. The second half of the century, I feel less confident. The projections for 2100 and beyond, personally, I have no confidence in them. Finally, there's changes in land water storage. If you mine groundwater, it winds up in the ocean. That is effectively, it raises sea level. If you dam a river and you keep the water from running into the ocean, that effectively, you would project lowering, a reduction in sea level compared to what it would have been otherwise. This is a minor term. I am not going to talk about it during the rest of this talk. Okay, so here are the trends in sea level recently. First of all, global sea level rise was about 20 centimeters between 1901 and 2018, but the rate more than doubled. But it was about twice as fast between 2006 and 2018. In other words, sea level rise is accelerating, and you can see that in these curves, which give the different sources, oceans, expansion of the different levels of the ocean, glacier melting, Greenland, Antarctica. Forget the water storage term for the time being, and this is the observed. So what that tells you is we can just about account for the amount of sea level rise that has been observed by adding together the different pieces that we think are dominating. In other words, there's nothing really missing. This is a pretty good agreement. The thing to watch is that these two pieces here, the light gray and the dark gray, which are Greenland and Antarctica, you notice they're bending upward. They're accelerating. They've been contributing more and more over time. Basically, if you went all the way back here, just 30 years, they were contributing net about zero. So the contribution of Antarctica and Greenland has accelerated. That's due to melting, not just melting, but ice as it warms moves. And it gets to the coast. It runs in glaciers or rivers of ice called ice streams, and when it gets to the coast, it forms icebergs. Those icebergs are fresh water being dumped into the ocean. That causes sea level rise. In fact, melting and dynamical motion, flowing of ice, from the ice sheets make about an equal contribution. So the bottom melt line here is sea level rise is accelerating, and the reason it's accelerating is the ice sheet contribution, to a lesser extent the thermal expansion contribution. For the future, the big uncertainty and the big contribution is from those two ice sheets, we expect, I should say. And you can see that here. If you go back to the period 1972 to 1980, on this map of Greenland, blue represents areas that are gaining ice, red represents areas that are losing ice, and you notice there's a lot more blue than there is red. Move forward to 2010 to 2018, and basically in Greenland, it's all red. That is the melting and the motion of ice off the continent, the melting of, let me go back. The melting of ice, no, I can't keep my hands in the right place. Sorry. The melting of ice and the flow of ice off the continent together have overwhelmed what used to be gains in ice from increased precipitation. So we are losing ice now more and more rapidly from Greenland, and a lot of it isn't the standard melting, which is the light red, it's the dynamic part. And the reason I focus on that is the dynamic part is the hardest part for us to model. We do a good job at modeling the melting, we do a questionable job on modeling the dynamics from both Antarctica and Greenland, but as I said, the situation is even worse for trying to model Antarctica. Why? Here's Antarctica with the, sorry. Okay. Here's Antarctica and the surrounding continental shelf, particularly the dark blue areas, but also much of the light blue area. Well, blue means that the ice, where there's ice, is bedded below sea level. That is, the ice is sitting on bedrock or sediment that's below sea level for two reasons. Part of Antarctica, particularly West Antarctica, is naturally below sea level. That is, the continent, the plate that it's on, and the land is all below sea level. Another reason is there's a lot of ice sitting on the whole continent, and that ice weighs a hell of a lot, and it pushes the land down. And that means that actually, as we lose ice from Antarctica, the land starts to move back in the upward direction, which is an interesting part of the problem, which I won't talk about now. But what's important here is when you have ice bedded on a surface that's well below the ocean, under many circumstances, that ice is unstable. It's not going to stay on that. It's not going to stay bedded comfortably on the rock below or the sediment that's below sea level. It's an unstable situation, and if you lose a little ice from the edge of the ice sheet, it tends to encourage the motion of the ice off the ice sheet. I won't go into details about why that happens, but you'll just have to take my word for it. This is a situation that exists around the edges of Greenland to a much lesser extent than in Antarctica. Almost the whole West Antarctic ice sheet over here is bedded below sea level, and some of it appears already to be unstable. And I want to walk over here. That's this area, the Thwaites and the Pine Island Glacier over here, at least the Thwaites Glacier, which contains about a meter and a half of sea level rise should it all disappear into the ocean, appears to be moving unstably into the ocean already. In other words, we may be committed to a meter and a half of sea level rise no matter what we do. This shows, again, the net mass balance of Antarctica. The purple is the total Antarctic mass balance, and the West Antarctic mass balance, the potentially unstable part I pointed to there, is the greenish or bluish here. So most of the negative mass balance of Antarctica is due to what's happening over there. Let's see. Okay, Now I'm going to flash to the United States and talk a little bit about what this sea level rise is actually doing in terms of how it affects people. And I wish I had a graph like this for an area of Southeast Asia, but I do not. So you'll have to accept my parochialism on this. This is years from 1950 to 2015 or 18. These are different states along the coast. And this is the number of days in which they get what's called sunny day flooding. This is also called nuisance flooding. It's basically, there's no storm, but there's a high tide. And that high tide is high enough to flood infrastructure. So significant infrastructure usually is built somewhere between, so it's at least 30 to 60 centimeters above mean high tide in my country. And so we can see the number of days on which we got this kind of flooding was very low. It's, 0 to 5 basically. Maybe there's a 10 here for one state. And back in 1950, but now as you get here, the number of sunny day flooding days has gone way up, in some cases an order of magnitude. That's largely due to sea level rise and partly due to, in some places, more infrastructure has moved into risky places that it shouldn't be found in. So this is sea level rise is having effects already. So how much confidence do I have in the idea that this will continue? Because I want to talk about what's going to happen in the future. Well, the trust that I and the IPCC have in the models which calculate thermal expansion is pretty high. We have high confidence. That part we're not going to be wrong about. Mountain glaciers, same thing. A little less confidence, maybe medium, and that's only because of the complication of certain glaciers. Of course, it's a balance, the amount of mass they have between precipitation and loss of ice due to melting, and that's hard to calculate because the models are not very good at projecting the precipitation amounts at particular locations. Degradation of, and meaning loss of ice from the Greenland and Arctic ice sheets, as I said before, medium confidence through 2050, progressively lower confidence thereafter. I'd say no confidence after 2100, except the number is going to get bigger and bigger unless we manage to get a handle on emissions. And why is it that it's so hard to model the base of the ice? It's because nobody lives at the base of the ice. You can't get under the ice. There is no direct measurement which tells you all the details you need to know about the base of the ice to be able to model it. And that's because small areas of the ice, areas that are, a kilometer square, can themselves slow down the motion of ice if they're rough enough at the base. And so getting a picture of the base, there are many indirect methods, that is a problem for, observational, people have ideas about how to do it, but it hasn't been solved yet. Also, you'd be surprised how little we know about what ice actually does when it's, thousands of tons of ice being pushed by gigatons of ice behind it toward a coast on a base that we don't understand, and the ice itself isn't pure. It's dirty in various ways. We don't know what the dynamics of the ice is, how it crumbles and falls apart, how it interacts with ice near it that isn't moving, and how it interacts with that unknown base, or the base that we have a lot of questions about what its properties are. And it's under this huge pressure. We just don't know. And then the interaction of the oceans is also a source of great uncertainty. Now, I don't want you to think we don't know anything, and I don't want you to think the modeling situation hasn't gotten a lot better. In the about 25 years I've been paying attention to the question of the ice sheets, the modeling has gotten a lot better, but there's still a long way to go. And a lot of what we're finding out because it's a response to the warming. So, you don't want to be in a situation where you found out that sea level is going to rise 5 meters in 100 years because it started to happen before you could do anything about it. And unfortunately, we may be in just that situation. So, What about the future? What do the projections look like? So these labels are different emission scenarios, from a very high and very unlikely emission scenario called 8.5. These are IPCC designations, to two very low and, in my view, unattainable ones. I hate to be a pessimist, labeled 1.9 and 2.6, which basically correspond to the Paris Agreement's 1.5 and 2 degrees of total global warming. I think we will exceed those limits before we come back to them, and that's because we're very slow getting off the dime, as we say, in actually doing something about the problem. And so the sea level rise, according to these estimates, by 2100 would range somewhere between, if we got really lucky, 0.5 meter, and if we're really unlucky and we're wrong that emissions can't get all as high as that 8.5 scenario says, something over 1 meter. But look at this dash curve. That takes account of the fact that there is what's called ambiguity, complete disagreement about what really will happen to those ice sheets as we approach 2100, and they could start leaking ice faster during this century. This isn't guesswork. These are different ways to estimate the loss from the ice sheets. Some of them are sensitivity tests. Some of them are expert elicitations, which are a way of finding out broader sets of expert knowledge than are represented in the models, which are incomplete. And some of them are models that some scientists believe in, but others don't. But the point is that our scientific judgment runs beyond this range, which IPCC rates has a 66% likelihood of happening. And if you think about 66%, that means there's 34% of outcomes which IPCC tends to say probably aren't going to happen. But what does probably mean? And what if you're in the risk management business? Are you supposed to ignore the fact that there's maybe 5 or 10% chances you could wind up here? Is that the way you protect a place like Singapore? Is it the way you protect a place like Rotterdam? Is it the way you protect a place like Manhattan? When people think about these things and who are responsible for risk management, they take this stuff into account, at least to some extent. They give it some weight, and that's why we have it on this graph. And IPCC, in fact, in its last couple of reports, said that risk managers should think about these unlikely but high impact type outcomes. And so that presents a real challenge, because some of these outcomes now come close to 2 meters as you get towards 2100. And of course, if you go beyond 2100, if you regard most of the outcomes that are projected as speculative, even in the low emission scenario, you're getting something between 0.5 and 3 meters sea level rise. And in that high, very high emission scenario, you're getting 2 to 7 meters. This is in 2300. But the possibility, based on looking at what happened in the distant past to sea level, is that you get up to something like 10 meters. So are we supposed to worry about 2300? Think about it. Do we plan for 275 years into the future? Should we plan for 275 years in the future? When you build coastal infrastructure, how long do you want it to last? How long do you want it to be good for? How long do you want it to protect people? When you think about settlement and decisions about where people should settle, how much do you want to worry about what century? Most people don't worry about even their own children and what's going to happen in their children's lifetime. Frankly, there have been psychological studies about this. Individuals may not worry about it, but what about people who run governments? How far in advance should they be concerned? This is something that we all need to consider. Okay, and there's yet another complication, which is that sea level rise, the global mean sea level rise, does not represent what happens at every inch of the Earth's surface, because there are several reasons why sea level actually sea level change varies from place to place. And they are because thermal expansion and changes in the ocean circulation, like changes in El Nino that happen with climate change, we think, are non-uniform. They're different from place to place. Whoops, there I go again. See, I'm getting better. It's been 5 minutes since that happened. My IQ just went down. I won't argue. So just look at the dots. I'm going to put this behind my back. Second dot. As sea level changes, as ice moves into the ocean, you change actually the moment of inertia of the Earth. It starts to rotate at a different rate. It starts to tilt in a different way. And the Earth, and in fact, if you take a little ice off Antarctica or Greenland, as I said a few minutes ago, you know, the shape of the Earth underneath where the ice sheet used to be changes. And in fact, the ice sheet used to attract water to its location because it has such a big mass that there was actually a bulge in sea level around each of the ice sheets. So as they lose mass, that bulge is going to diffuse into the ocean. All of those factors, the rate of rotation, which, essentially the change in the moment of inertia of the Earth, changes the bulge of water around the equator. The deformation responses to the underlying mantle mean that the ocean basin shapes change. The gravitational attraction that the ice sheets used to have for water lets that bulge around them diffuse, and that changes sea level at every location around the surface of the Earth. That's a very hard calculation to get right. So we start out with a difficult calculation and trying to figure out what the sea level change will be in, say, Singapore versus Hanoi versus let's pick someplace on Cape Town, for instance. Different continent, different area of different continent, different sea level rise. And then there's there are tectonics. There's a glacial isostatic adjustment, which is a recovery from the last great glaciation when there were big ice sheets in the northern hemisphere. That retraction also is changing the shape of the solid Earth. And then on top of that, subsidence due to human-made changes, like as is happening, for instance, in Jakarta, which is causing quite a lot of problems there. And there is some issue about some subsidence here and whether it's going to continue. All of that makes the calculation of local sea level rise at any particular point very, very difficult. And then finally, I know this is a headache, but this is what I got to deal with, so you got to watch it too. There's what happens when a low pressure system comes around that reduces the pressure on the ocean surface, and it also pushes water toward the coast in some areas because of the counterclockwise winds in the northern hemisphere. And what happens is that you get a surge during a storm of water bulging up against coastlines. And that is what causes, in my area of the world, the highest of the high tides. But on top of that, of course, you've got high tide, low tide, you've got the waves hitting the coast, washing up in a process called swash. You have to add all that together and do to get a useful calculation for what the risk at any particular coastal location is from either high tides or a storm. Now, I don't want to go through the details. This is part of the business I do, with how do you transform all of that from data that we have available from tide gauges into useful calculations of what extremes of high water are along the coast at any particular time. I can't obviously go into detail about this now, but take it from me, it's a difficult calculation. There is another way to do this, which I'll talk about in a second. Let me just show you what the results of some of these calculations are. We couldn't do it for Singapore because you didn't have a long enough tide gauge record for us to take the tide gauge, the historical high water, add sea level rise and convert them into frequency of high water in the future. But we did it for about 170 or 80 locations around the Earth's surface. These are some ones that are reasonably near here, a bunch of areas in Malaysia, and then there's Australia. Most of these locations only are subject basically to high and low high water due to high tides, and sometimes a combination of high tides with, say, El Nino. Australia, this location is subject to tropical cyclones once in a while. And here's the high water. This is the high water mark in the so-called 100-year event, the event that has a 0.01 probability of happening in any year. It's a sort of an international benchmark for a bad potential flood. The high water marks range from here 2.41 meters above mean, highest high tide, 2 tides during the day, 2 high tides, 2 low tides, to much lower amounts of rise in Malaysia, and that's because these are not storm-driven. These don't have storm surge. These are basically high tides. And what these numbers are worth, now pay a little attention here. This is for year 2050. This is for year 2100. This is for year 2150. This is if we get 1.5 degrees warming above pre-industrial, 2 degree, 2.5 degrees. And these AFs, these are amplification factors. This says how much does the 0.01 probability per year increase as you let the world warm through these 3 time slices for warming of 1.5, 2, and 2.5 degrees. And you'll notice the multiplication factors here are about 100. But they vary from 20 to 154 in this column. They're bigger here, of course, as a warming. You get higher multiplication, more frequent high water. Here they're in the thousands. That means, what does that mean? If you take something that would have happened once a century, and you multiply its probability by 100, you're getting something that happens once a year. In other words, the once in 100-year event, according to this calculation, at this location, these locations, happens every year. How do you adapt to that? Something that in some cases actually is a very damaging event, all of a sudden it's happening not less than once in a lifetime, but 100 times in a lifetime. How are we going to deal with that? And in this case, these cases, multiplication factors of thousands means it's basically eventually happening on many high tides through the year. In some places, it happens on every high tide, that you get a multiplication which is so radical that you're taking something that almost never happened, and due to sea level rise alone, this has nothing to do with storm intensity. It assumes fixed storms that all of a sudden the event, the high water mark, is coming every day. This is a radical change in what people are used to dealing with. And even if these calculations are off by a factor of 2 or 3, which is entirely possible, they still indicate a severe change in risk. Now, there are a lot of limitations with these calculations, and the only way to get anything more accurate is by hydrodynamic modeling. As I learned tonight, we do some hydrodynamic modeling here. I'm so sure you guys do some hydrodynamic modeling. And what happens there, the trouble is that the current hydrodynamic models, they're expensive to run at the resolution you need, and also they don't do tropical cyclones very well. And that may not be a big issue for Singapore, where you may be able to do a good calculation, but it's not very helpful for New York, and that's why we still rely on extrapolation from tide gauge data or transformation of tide gauge data. This is the tide gauge at Salton Shoal in Singapore, and you'll notice there's an upward trend there. You'll notice there's a lot of variability, and there's a lot of variability on these are monthly readings. There's a lot of variability on the fair amount of variability month to month compared to some other stations. But you've also got these longer 2 and 3 year or 5 year patterns, which probably results from El Nino. But you also notice the record is broken in certain places, and that's why we were unable to do a reliable calculation on your amplification factor. This is the longer. This is the longer-term average curves for transforming this and 3 other stations. And basically, you're seeing this upward trend, just like everywhere else along the world, overlay with this noise pattern of every few years. So that's a projection for sea level rise for Singapore, but again, and that's what you'd expect. It looks like a lot of other places around the world. The standard deviation from the global mean sea level rise is about plus or minus 30%. So the projections are, the measured data and the projections are all rather consistent. Now, what do you do about it? I've got about 15 minutes left. Let me give you some of my ideas of what can be done about it and what actually might be done about it. So, adapting to sea level rise. There are basically 6 generic ways of doing it. One is do nothing. Just sit there and think about it. This is what a lot of governments are doing. That's not a good answer. I won't even explain why I think that that's a dumb thing to do. You can build protection, like a wall, like a surge barrier, like a barrage. It works up to a point. It's expensive. By the way, the bottom line is you're going to need all of this except the do nothing. But it costs a lot of money, and it has the disadvantage of being concrete and steel and hard to build there are ideas about building flexibly, so you can lay down some concrete and steel, and if you're wrong in your estimate, you could build on top of it later. That's called adaptive management, and it's a great idea. It's the way things should be done. Think ahead, but it is costly, and financing these projects is not easy. There's accommodation. Accommodation is what we usually do. We usually do something which will work, and in the normal world, in the past, it's worked very well. You can raise houses, for instance. You can create floodable zones. The trouble with the limitation on doing things like accommodation, which are absolutely necessary and a lot cheaper than doing this, is in a dynamic world with dynamic sea level rise that's only getting dynamic in one direction, it doesn't work forever. You're going to have to do something else in 10, 20, 30, maybe 5 years. So this is not a permanent solution, but it is a good thing to do while you're thinking about doing maybe something more expensive. There's advance, which has got a rich history. It's what the country, the Netherlands, is all about. It means reclaiming land, essentially, or not reclaiming, but claiming for the first time by creating new land, building the coast outward. It is itself not cheap. It's expensive. It creates new land, which can have economic value, but it also creates environmental problems. And to give a trivial but politically non-trivial cast on it, a lot of people in rich countries move to the coast for the view, and what does it do when you build houses in front of them? People are not happy with that, and a lot of these people are very wealthy, and that gives them political influence in countries like my own. So this is not a simple solution. There is retreat, which ultimately there will need to be a lot of retreat around many areas of the world's coast. That is, there are areas where they're not going to be able to get the government's attention, where this will not last, this accommodation will not last forever, where the money won't be available to do hard protection, and where people are going to have to move. People already moved due to coastal problems, let's face it. This is an optimistic view of moving a house backwards. A lot of places you can't do that. The land belongs to somebody else. Retreat is now being carried out officially in many countries, including my own, where the governments pay people to move out of areas which are threatened by sea level rise. This is going to be, I predict, a big part of solving the problem, because in much of the world we cannot afford to basically put the right amount of concrete and steel at every place on the coast, and nobody's ever built a wall that wasn't eventually overtopped anyway. So, and this nature-based or ecosystem-based adaptation is the newest research area. Restoring wetlands, restoring dunes, building areas which out of shell reefs, for instance, like oyster reefs, traditional in where I come from, New York Harbor, they used to dump oysters. We used to have a huge oyster crop. So they dumped the used oyster shells after people ate the oysters. They'd build big mounds of oysters. Those actually had a wave-breaking effect, which was very useful. There's been a new interest in looking into doing just that. The difficulty with this is it's a good research area. It needs to be implemented. We're doing a lot of implementation with wetland preservation and extension, but we don't have good data yet on how effective and how costly it is. But this is there's a lot of hope and aspiration around ecosystem-based approaches. And just to remind everybody that none of this is, the new part in this is a dynamic part. People have been living their lives accommodated to coastal flooding forever. Let's face it, as long as people were near the coast. And this part of it, building gigantic concrete and steel barriers, is what in human experience is relatively new, but quite effective in many cases, up to a point. And this is an example I like best, and actually, I started showing this in a different context 30 years ago when I went to Bangladesh to look at the sea level rise situation there. They had terrible experience, and still do, with tropical cyclones coming up the Bay of Bengal and killing in 1970 as many as, well, the numbers went up to 1 million people. People now use a number like about 500,000 for what probably happened. Imagine that, 500,000 people dying in one tropical cyclone. That was one of the things that triggered Bangladesh didn't exist then, it was East Pakistan. And it helped trigger a civil war that might have happened anyway, because there was a terrible, an ineffective government response. But now what do? Well, they have a great early warning system, which was, they could mobilize it because of advanced forecasting, which is a global, not Bangladeshi invention. But they used the information, they built concrete bunkers so people had a place to go. And now the death rates in cyclones, which are a regular phenomena there, are down in a couple of thousand. That's still a lot of people. If it happened in my country, people would be going nuts. But it's a hell of a lot better than 500,000 people. And if you compare it to what goes on in Myanmar, which is right next door, where they get the same kind of cyclones, there 10 times as many people die. And the difference is that governance is better in Bangladesh than it is in Myanmar at this point. And they're able to get things done. Again, this isn't perfect. As sea level rises, the problems along that south coast of Bangladesh are going to get worse and worse. But as an accommodation measure, hey, it saves a lot of lives. So the good news is adaptation, and this is generic. It's not just about coastal adaptation. It pays. According to a study that was done for the Global Commission on Adaptation, which had the Blue Ribbon Commission with a lot of famous people like Bill Gates on it. I don't know what Bill Gates actually knows about sea level rise, but he was willing to lend his name to this, that you save $2 to $10 depending on what the impact is you're trying to avoid by planning in advance rather than spending it afterwards to clean up. Despite that in enticing economics, countries are not doing nearly as much on adaptation generally, and coastal adaptation in particular, as they should. I'll criticize my own country on this. Adaptation, our system for adaptation didn't exist until recently. It's only exists since the middle of goes back a little bit to the Obama administration. A little bit was done during the Trump administration. A lot is being done in the Biden administration, but it pales in comparison to the scope of the problem and the resources needed. What we did was emergency response and recovery. That's what the US did. And to deal with adaptation, we tacked a little adaptation onto a system that was built for emergency management. And that's not a way to manage a problem that requires a lot of thinking ahead and thinking not what the next disaster is going to bring, but how you avoid that disaster with a, say, 50, 75, 100-year perspective. And that's that failure to set up a forward-looking planning process instead of an ex post process, which is let's clean up afterwards, is what to this day is an anchor around the neck of the U.S. in trying to adapt to climate change. We still do not have a way to adapt not only effectively and efficiently to coastal risk, but to heat-based risk, to fresh water, too much precipitation inland. None of it is done well in the United States, despite good intentions on the part of the current administration. Of course, it's an institutional problem. It's a governance problem. It can't be fixed overnight. So let me talk a little bit about what those obstacles are. And this applies, it may not apply to Singapore, which is a vertical governance structure. It's a small place. Presumably, it's easier to get things done. It's a nice place for other countries to come and learn what a system looks like that can be efficient that way. It's not applicable in every country. My country has a federal system, entirely different than your system here. It has its advantages, but in adaptation, it has some marked disadvantages. But before I get to that, there has been some good news. Global mortality in tropical cyclones is actually decreasing, and that's undoubtedly because of weather forecasts being better. In the U.S., which is a very well air-conditioned country, heat mortality is decreasing. The question there is, can we keep up as climate changes? And the thing about heat adaptation in the United States, the government doesn't buy air conditioners for you. It's a privatized activity. People who can't afford air conditioning, they're out of luck. And as we get more and more heat, we're getting that tested now. We're getting that tested this second with the heat dome that's sitting over the southwestern United States. Will a privatized system work? Who's left out? That's why you hear a lot about equity in the United States, the equity issue in the context of climate change, because it casts a new perspective on what's really an old problem. And so that gets to that issue at the bottom there. As the climate changes and we have to race to keep up with the changing climate, will we be able to? And just a couple more slides. I like to use this example. I'm actually sort of ashamed of it because I live in New York City. I was born in New York City, and I love New York City. And one of the most fun you ever have as a kid is riding on the subway system in New York. It's a great public transit system, and it's the lifeblood of the city. If the subway were to go away, the city economically would be a disaster zone. We've gotten through a lot of disasters in New York in the last 20 or 30 years, but if we lost the subway, we wouldn't recover, is my view. And so what happened? Well, let's look at Hurricane Sandy. This is a perfect example of terrible planning, of knowing there was a threat and being totally blind and doing nothing about it. This is the high water mark in the total of 10 highest flood levels along the coast in New York. And then Hurricane Sandy there were 9 of them, and Hurricane Sandy's the 10th. These were either hurricanes or coastal cyclones that were not tropical, that we call northeast storms. This is the level, the dotted line here, at which the subway gets flooded. So at a level of 10.5 feet, translated to meters yourself, above, this is mean lowest low water, you get water into the subway. If you get salt water into the subway, you corrode the wiring. The signal system is old. You can't just go to a hardware store and buy a new signal system for the New York subway. If that system corroded and essentially became inoperative, the subway would have to shut down for months, maybe more than a year. That did not happen during Hurricane Sandy, but Hurricane Sandy was the first time that salt water got into the New York subway system. Now, you might ask yourself, or you might say, okay, but the tide in Hurricane Sandy, the storm tide, was about 4 feet, a little more than a meter above any of these previous storms. So you say, you can't blame the leaders of the city. You can't blame the leaders of New York State. They really thought this was a 1 in 300 year event. It just was never going to happen. But if you look here, you'll notice that most of these nine events almost flooded the subway. Now, what were these people who were governing, responsible for the safety and health of the city, doing when there were 9 events that came, some of them, a few inches within flooding the subway? And how much did they do to protect the subway system? 0. Nothing. Nothing at all was done. This was a personal experience, the best example I can give you about how not to do planning in a rich city, in a rich country that had access to all the expertise in the world and did nothing to protect what's essentially its most valuable commodity, aside from maybe the water supply system. So that's an example of how decision-making can completely fail. I could give you a million reasons why it happened, and I'll give you a few. There are physical factors. If you look back, you'll notice, this is no excuse, but I'll show it anyway. You'll notice that part of the reason, these are various contributions to the storm tide. There was a high tide, okay, and it was a storm surge, which was really big, but there's this chunk of about a foot and a half of sea level rise. It was a foot, actually. So there's a foot of sea level rise out of this 10 feet, and it was growing, obviously, since the early 1950s. All right, they knew this was happening, by the way, but they just decided not to pay attention to it. So, situation, though, was changing. The situation is changing at every coastal location. How many places are they just going to sort of not take advantage of the fact that we now have predictions which are reliable over the short term? Secondly, this is especially challenging now because these events, like Hurricane Sandy, a 1 in 300 year event, all of a sudden it becomes a more common event because of sea level rise. That's a hard thing to plan for. And these events are going to become more and more frequent. So that's good in a way, I hate to say it, because you get hit, you learn. We'll get hit more and more often, we'll learn. But the trouble is the rate at which we're going to learn is not going to be fast enough, I don't think, to deal with the fact that the gap between events is shrinking so much. And every time we get a bad event, we get so much damage that the recovery takes, as I said at the beginning of this talk, more than a decade. There's insufficient time to recover before the next event happens. That's a very tough situation to try to deal with as a planner. Then you add on top of that the projections get rather uncertain beyond 2050. So long-term planning becomes something that involves iteration, adaptive management, adjustment continually. And governments are not so good at that at this point. But we can't, the basic approach to this by governments would be just wait until we know more, but you can't because, as I said, it takes 30 years, 40 years, 50 years to get a big project done. Even in a well-organized country like Singapore, what about a country with a fractured, multi-level governance system, federalism like the United States? I love federalism. It's great for certain things. For this, it's not so good. And it isn't just the United States. This is the famous 1953 storm, which killed a couple of thousand people, more than a couple of thousand, in the Netherlands and the UK. The coastal defenses in the Netherlands had deteriorated, probably because of 2 world wars, a depression, and who knows what else. And in the UK, same thing. There were no coastal defenses in some places. And as a result of this killer flood, all of a sudden, the coastal defenses coming out of that flood were modernized. The building of the renowned modern defenses, for instance, around Rotterdam in the Netherlands, and the building of the Thames Barrier in the UK, which now protects London. Bad events are what cause good investments for the future. It's a stupid way for humans to act, but this is what we do. In New York, we did a study comparing New York's adaptation to coastal risk versus Shanghai. Shanghai has been hit by typhoons, big ones, 1962, 74, 81, and finally Typhoon Winnie in, I think, 1997 hit, and it was fairly well protected by then. New York didn't have the experience of being severely damaged by any storm in the many decades preceding Hurricane Sandy. The last big hurricane of anything like that magnitude was like 1823, and there wasn't much city there at that point. So there was no learning experience. So unfortunately, we have to change this. If we keep only responding after getting clobbered, we're always going to fall behind. We have to think ahead of the next storm and ahead of the 10 storms after that if we're going to actually survive this problem without severe economic damage on a continuing basis. Then there's the psychological problems. People and institutions have both people and institutions have short memories. How do you establish governments that are willing and able to do long-term planning so they can remember what the last event did and they can decide to plan ahead and remain focused on actually completing the job when all this other stuff that I mentioned before is happening in the meantime, things that might have nothing to do with climate change? How do we get governments to pay attention? And then there are these perverse political incentives that in most countries, governments don't last more than a few years. And so what the focus is on is not spending too much money so that you'll annoy the population. This is a US dynamic in particular, but also Europe. How do you raise money for these projects when if you spend the money now and you start taxing people, they're going to vote you out of office because you'll never get the credit because it's unlikely that A, the project will be finished in time while you'll still be in office, or B, that if you do finish the project, that a bad event will happen that'll cause the project to look necessary. How do you get over that dynamic? I honestly don't know. It's very difficult. And then there are things about the governance structure of even our best governed countries which inherently are difficult to deal with. And in the US, the problem is that finance, the biggest tax resources go to the federal government, but the responsibilities are to large measure, not completely, for implementing adaptation at the state and local level. And to a lesser or greater degree, that problem exists in many countries, although in some it doesn't. One reason the UK could build a surge barrier and that China has done some interesting things, not on adaptation, but on emissions mitigation, is that they have a more unified vertical structure. As I said, federalism is a great thing in many respects. It works very well with experimentation, for instance. But this is a problem which will challenge the virtues of federalism. There are some fixes. We have to fix the finance system in the countries that don't have a uniform way to distribute resources and to collect them over decades to make sure that you don't need a bad event to all of a sudden get the government to be willing to spend money, that there are pools of money that the implementing authorities can draw on a continuous basis, that they know will be there when they need it, because adaptation has to be built gradually over long periods of time. As I said, the governance structures, the institutional arrangements, insurance is a very important part of this. There are insurance pools have to be designed to not only be available when the payments have to be made, but also so that they provide incentives for people to not rely on insurance, but to do the right thing individually to the extent that adaptation is partly an individual problem. I've mentioned the dynamic adaptive policy pathways, another brilliant invention by some Dutch scientists. And we have to legitimize retreat. Retreat is looked down upon in a cultural sense. And that's not good because retreat is going to have to happen. It is happening already. How you change human psychology, how you transform the sort of the way human beings think about these problems, how you transform the way the political systems think about these problems. Those incentives are beyond me. I'm not a political scientist. I'm not going to fake it that I have an answer for it. So there's the big question. Will more extreme events arrive faster and faster in a way that stimulates political action, or will we still continue to lag even as we're getting clobbered with these events, and the result will be we'll never really fully recover, and it'll be the gradual depression of economic activity as we spend more and more fraction of our national income on fixing up problems that we shouldn't have allowed to happen in the first place. Thank you. I'm sorry I ran over my allotted time, and I look forward to answering some questions.
Thank you, Professor Oppenheimer, for your thought-provoking lecture. Now I would like to invite the audience in this room and also the audience online to raise your question. So our staff will be walking around with wireless mics to help you.
You want me to sit down? Okay.
Questions, anyone?
Yes, please.
Thank you, Professor. Very interesting lecture. And it's interesting in a way that you talk about the problems in the States as if, because of the fragmented governance there, so a lot of the time then they're not able to plan long-term ahead. And at the same time, you give the example of like Shanghai versus New York. Interestingly, if you think about it, Shanghai people actually cannot vote their government out just because they didn't react. But the New York people actually can. But in that circumstances, why do you think that is it that the science hasn't provided enough information for the public to really push their government to do that? Or do you think that there's something, because we talk a lot about the projection, about uncertainty, but for example, for Singapore, whether the sea level rise in 50 years is 1 meter or 2 meters, they need to do something. But other than Singapore, a lot of the places actually still do nothing. So where do you see is the missing link there? Thank you.
Well, on the first part of that, I don't. First of all, there were a lot of reasons why Singapore could do some things that are hard to do in the United States. It's not just, there's a more uniform governance system, and they also were treated, as I understand it, specially by the national government in terms of their ability to make decisions on their own and not wait for a national decision to be made. So they had a lot of flexibility, but even with that, it's pretty remarkable that it took, learning from not just one storm, but floods from 3 storms. So maybe they've got the same disease that the United States has, and their different governance structures can make up for a little bit of it, but in the end, we're all human beings, and we're all subject to these same biases, which have to do with not thinking too, myopia it's called. You don't look too far in the future. We can barely see, essentially, because that's the way we're wired, and we're fighting that. And whether we're individuals or government officials, we're fighting the necessity here of thinking ahead 50, 75, 100 years. And it's a very hard thing. And we're actually asking human beings to do something that they rarely did before. On the other hand, there are some good examples. In the United States, in my city, in New York, which I've just slammed all over the place for not doing the job that we should have done, actually we built a water supply system beginning in, I think, 1823, where originally it was because of a yellow fever epidemic, and we didn't know how it was spreading, so we took the guess that some of it had to do with the water supply system, cholera, not yellow fever. And the guess was right, and it started a process of building well in advance, and it became sort of an economic thing. But let's expand the water supply because more people will come. That was a time when it wasn't already so densely populated. And so there is, when the incentives are, when you have a reason to think ahead and do something. There have been governments, there have been people in all parts of the world that have done it. It's just that it hasn't been done big enough and often enough to be on the scale that we need now for not just coastal protection, but a lot of other changes related to climate change, such as fresh water management and what's going to go on with flooding inside the continent. So I certainly don't mean to argue that the Chinese governance system is better than the U.S. government system. All I'm saying is there are situations where certain features of any government get in the way of doing something right, but human nature is a problem for all of them, for all systems.
Okay, thank you. Any other questions from the audience?
Maybe we can take some questions from the students.
Hi, there's a question online. The global environment is shared by the global community, though rational stakeholders has assumed in economics only care about their own interest. Would you be optimistic about global warming prevention-related policy design to prevent the tragedy of commons?
That's a big question. What you're actually asking is, at a larger scale, can you expect humanity to sort of cooperate because we have a common problem with a common resource, which is the atmosphere and its ability to tolerate the additions of carbon dioxide and other greenhouse gases? I think it's an experiment. I don't think we know. I'm an optimist, but that has nothing to do with reality. It has to do with my mother didn't drop me when I was a baby. Who knows what it has to do with? So my view is, you have to be optimistic about a problem like this, or else you'll give up hope. And the fact is that human beings have done some remarkable things. And we have got societies and governments that manage to get together and take collective action on problems in ways that have been very helpful have brought us progress in a way that would not have happened otherwise. And the general condition of humanity is better than it was 10,000 years ago. I completely believe. But if we at the same time that we make that progress, we get the ability to throw bigger and bigger problems in our way. And we're very good at creating problems, and then we're also very good at figuring out how to solve them. And one of these days we might run into a problem we create that we don't know how to solve. And so the latest enthusiasm about an unsolvable problem is AI. I don't know. I have enough headaches with climate change. I don't want to go over to AI at this point and worry about it. But I think that we are capable. The question is, we've gotten so good at creating problems, how many of them can we create at once? And we reach a point where it exceeds our ability to balance that many, to juggle that many balls in the air and solve that many problems at once. I don't want to think that we've reached that point. And so I want to believe that this problem is solvable. Can I prove it? No, obviously not. Like I said, come back in 50 years.
Thanks. There's another question. Would you please comment on how we evaluate the potential effectiveness and trade-offs with shoreline hardening projects? In terms of effectiveness, I'm thinking of groundwater rise, and in terms of trade-offs, what are some of the ecological considerations?
I didn't understand the very beginning.
Would you please comment on how we evaluate the potential effectiveness and trade-offs with shoreline hardening projects?
Shoreline
hardening
projects. Oh, my view on any of this is that, as I said, we're going to have to use all of these in combination mostly at different places at different times. And except for the no action approach, I don't think we can write off anything. I will say that because of the scientific uncertainty, in my mind, translate scientific uncertainty into leave a margin of error. And in this case, what it means to me, in particular, is leave a buffer zone. If you're going to build concrete and steel, it should be integrated with buffer zones, because concrete and steel. There's always the next storm that's bigger where you didn't quite plan enough in advance and you didn't think about it, or your projections are wrong and you're over top. So you should be building, no matter what you build, with areas that are floodable, where you essentially can accommodate to the flooding, whether that means infrastructure like houses that are raised, or whether it means recreational areas, very well drained parkland that'll recover in a couple of days from a terrible flood. You don't have to build up to the very edge. You shouldn't be building up to the very edge at all times, which is the way it's been done historically. You have to and that's part of natural defenses. It's recouping those kind of natural buffers that nature gave us originally. And so we ought to orient our thinking as we do things that are unnatural to incorporate these natural features, because they are a way to tolerate flooding without losing a lot of economic value and human lives potentially in the process.
Thank you for that. There is another interesting question. Is the lack of planning ahead sometimes simply because the costs related to the SRR damages incurred are simply not yet high enough, and that we bounce back after large events or recover pretty fast?
Well, my argument is we don't really recover pretty fast, that there's a lot of lack of recovery which goes on for decades, and that in the future, if these calculations are right, which show a very large amplification of risk as storms, for instance, in this case, occur closer and closer together, or heat waves occur closer and closer together, or intense precipitation events occur closer and closer together, that tail of repairs that needs to be done really means you're constantly focused on an ever-growing pile of incomplete recovery. And that's a big economic drag, potentially. So I don't think the premise is correct in the question.
Okay, due to time limitation, maybe we have one more question from the audience.
Thanks for the presentation. Could you share a bit more on flood insurance? I have two questions. The first is, how do we find the right balance between protection and recoverability? And the second is, how do you overcome the problem of adverse selection, whereby only people in high flood risk areas will tend to buy such flood insurance, and it could end up pushing the premiums very high? Yeah.
Well, first of all, what happens if you don't have flood insurance is that, especially if, by the way, the premiums are tied to incentives to get people to behave more sensibly in terms of preparing for the potential for big storms or coastal flooding or whatever. The price is that essentially you're taking, the cost is going to happen for all the stuff you didn't do as a result, and it's going to wind up with somebody paying. So who pays? In this world, the reinsurance companies pay if the insurance companies are overwhelmed, or if the reinsurance companies either fail or move out, as is happening in the US now, the government pays. It's either the state government or the federal government, but somebody pays. Either that or nobody pays, and then people are left without the resources they need to prosper. So a properly structured insurance system is that combination of sustained ability to pay, somebody who's got a lot of money, or some institution with a lot of money, or guaranteed flow of income, which is why it's important that everybody participate, so the revenue is there, and at the same time that there's an incentive so that the cost of that it's going to cost after a big event happens is going to be lowered, because people took steps, because they knew that if they didn't, they would be penalized in some way. So for instance, in the US, I don't know what happens in Singapore or what the insurance system is, there is a law, essentially, that if you live in the flood zone and you expect to be repaid afterwards for damages, that you have to have flood insurance, which is federal flood insurance. But nobody goes around and enforces that. It was actually tied originally to people having home mortgages from banks that themselves were insured by the federal government. But that system is broken down because the federal government doesn't go around checking, the banks don't go around checking who hold the mortgages, and the insurance system is bankrupt basically because it's federally run, and every time there's a disaster and shortage of money, the Congress votes more money. So all the incentives are completely wrong in that system. And as a result, people are not doing the level, they're not themselves investing in the level of protection for their own property that they would otherwise if, for instance, there were a mandatory insurance system which was truly enforced, and where if you then spent money improving the flood resistance, for instance, of your own property, that you'd get a reduction in the premium on the insurance. None of that exists anymore functionally. So it's a pretend system we have, at least in my country. I'm not sure what the situation is in other countries. And the result is the federal government keeps pushing out the money after disaster, but there isn't enough action before disaster to reduce that ex post cost. And that system itself is a disaster. That's the biggest disaster.
Okay. Yeah, maybe last question.
Hello. I was curious about the extreme, what do you call it, the low likelihood, high impact of the moving ice sheets. Can you comment on whether that curve is on the likelihood of that happening in the next, I don't know, 40, 50, 100 years, and how soon before the research improves to better those estimates?
All right. First of all, I just want to go back and say on the other set of questions, I keep using the U.S. as an example. Every country I could point to, every big country, has a failure like that. I'm only picking on the U.S. because I live there and it's important to me. But I was surprised, for instance, someone who knows a lot about Germany, for instance, that the floods in North Germany a year and a half ago did the incredible damage that they did, where Germany had not done what it should have been doing with its freshwater flood defenses. So if I came back with a different hat and did the same talk, I would be extremely critical about some other country. As far as, I wish I could answer the question of how fast science would advance. There is no formula that tells us. All I can tell you is based on the rate at which progress is happening in the modeling and based on some fundamental features of the ice sheets, like they're hard to observe, or like you can't send millions of scientists down to Antarctica because the experience of living in Antarctica and dealing with those harsh conditions over long periods of time really limits the number of people who want to get into the field. And there isn't all that much money anyway to support it, and those people are heroes. Essentially, they sacrifice big parts of their lives to live long periods under harsh conditions to do the science that benefits us up at the higher latitude, the lower latitudes. So I can't answer your question. I can just say, based on our experience, it's a multi-decadal problem. And we're going to learn a lot about a lot of aspects of sea level rise as it happens, unfortunately.
Okay. I think now is the time to, sorry.
Okay, give him one more.
Okay.
If I can do it, he can do it.
Okay.
Yeah, thanks for a very nice presentation. I had a question also on these low probability, high impact events, and there was a remark on your slide like the risk-averse people or countries should pay attention to those and invest. But you also mentioned equity, and we can talk about equity at the national scale, but also at the global scale. And if we look at equity on the global scale, what do you say about these investments, let's say, on these very low probability, high impact scenarios in rich countries like Singapore and the Netherlands versus the very high likely lower impact or maybe also high impact scenarios in less developed countries? How do you think about that equity problem?
So first of all, that's one reason I showed the slide about Bangladesh, that there are things that countries that are well organized from a governance point of view, but have low economic standing in the world ranking. There are a lot of things they can do for themselves. I'm not saying they should be left on their own. I'm just saying it's in some ways it's not as desperate a situation. It's important that those countries understand that there are low-hanging fruit. There are simple, everything is complicated, relatively simple and relatively cheap things that are being left on the table that shouldn't be left on the table. But, from the point of view of equity, of course, this gets to the problem of burden sharing and reducing emissions. Whose responsibility is it? The U.S., if you look at the historical emissions, the U.S. still leads China. If you look at the current emissions, China is way ahead of the United States in current emissions. What does that say? Then you can look at it per capita. You can look at it per unit GDP. There's no end to it. What I think, I'm glad that the issue of loss and damage has been raised in the climate negotiations. I think it's very important, whether we call it compensation or something else. It's important that the developed countries that have the resources share technology, expertise, and money to help countries that have to do something and have tried their best but can't afford to do the rest to at least have a fighting chance. So you're asking a bleeding heart liberal here. Yes, of course I think we should share resources. It's very important. It's very important because some of those countries are going to be coming over the horizon in terms of being important emitters, as India is now. And what's their attitude going to be if we kept saying, oh, we dismiss you? Well, we might dismiss Indonesia today, but in 30, 40 years, they could have a roaring economy. They got a lot of people. It's going to be important. The Philippines, same thing. A lot of countries that people thoughtlessly might think aren't important in this problem. We shouldn't worry if they're going to have damages. It's not our headache. Well, they may have that attitude towards us in 50 years. Who knows? We are, in the end, stuck with living in the same world. We ought to do our best to behave like it.
Yeah, I think now it's time to close the Q&A
On that
session.
speech, we can.
Professor Oppenheimer, thank you so much for your valuable time sharing with us your ideas and thoughts on sea level rise and also coastal adaptations.
Thank you for having me. It's been a pleasure.
Thank you, Professor, for this thought-provoking lecture. As a token of appreciation, CEE and NUS Cities would like to present a plaque. May I call Prof. Kuteng Chai, Director of NUS Cities, to present the plaque to Prof. Oppenheimer along with Prof. Zaigang. Thank you everyone for attending this lecture and actively participating with your questions. Please watch out for our social media channels as well as your emails where we'll be informing you about all our future lectures. Thank you and have a good night.